Class, here we go. Section 6.2, apply properties of rational exponents. So section 6.1 talked about rational exponents, how to use them, what they mean. Section 2, we're going to apply properties. So I'm just going to show you a few properties on this screen right here. You already know how to do this property, right? X squared times x to the fifth. You would say, oh, they're the same base, so you add the exponents, x to the seventh. Right, x to the fifth divided by x squared. So, oh, same base dividing, which means you subtract exponents, x to the third, so on and so on. You can even do this with numbers, right? 7 to the third. We'll do this times 3 to the second, all squared, right? So you can't put these together; they don't have the same base. All we can do is say, okay, square this guy, square 7 cubed, so 7 cubed. Square that times square the other guy, so 3 squared squared, which becomes 7 to the sixth and 3 to the times 3 to the fourth. And I could keep going with that if I wanted to. So you get the properties. Those are some of the basic ones. We're going to use these same properties with rational exponents. So in this right here, you have 7 to some exponent. Exponent is 1/4. Times 7 to another exponent. They have the same base, which means we can add the exponents, right? I mean, if this was 7 squared times 7 to the fifth, you would add the exponents. So here we go. 7 to the 1/4 plus 1/2. So the deal is, if you can't do that in your head, you could type that in the calculator. Type in the calculator 1/4 plus 1/2 equals, you're going to get a decimal. You'll hit math frac and it'll give you your answer. So answer is 7 to the, you add these up, 3/4. Okay, next one. 6 and 1/2, 4 to the 1/3, all squared. So these can't be put together, 6 and 4. They're different bases. So we're going to square this one, and then we're going to square this one. So 6 to the 1/2, square it, times 4 to the 1/3, and square that one. 6 1/2 squared. Use power to a power. You multiply the powers. 2 times a half, 6 to the first. You don't even have to write the 1. Times 4 to the 1/3 times 2, which makes it 4 to the 2/3. There you go. And if this could simplify, you do it, but it doesn't. So letter C. Here we go. Now we have a negative exponent. Remember what happened when we have negative exponents? You flip them, like a to the -1 is equal to, as soon as I see a negative exponent, I do the reciprocal of this guy. 1/a to the, instead of -1, now it becomes +1. Same idea here. As soon as I see a negative exponent, I'm going to flip it. So this becomes, instead of it being on top, it's going to be in the bottom. 4 to the fifth, 3 to the fifth, all to the +1/5 power. So I just took this and put it under 1. So that's the reciprocal. Change to the +1/5. Here we go. We're going to use the property above. 1/5 to this thing, so 1/5 times 5, which is 1. So 1 on top. 4 to the 5th times to the 1/5 is 4 to the 1st. Here we go. 3 to the 5th to the 1/5 becomes 3 to the 5 times 1/5 is 1. 3 to the 1st. Now we can simplify that. 4 and 3. 4 times 3. So 1/12. There you go. Next one. So just be able to use your properties really well. Even though it looks weird because they're fractions, please don't get afraid. Just do what you would do. Change them to whole numbers if you want. Say, okay, I don't understand this, so let's make it 7 squared times 7 to the 5th. Oh, you just add them up. 7. 2 plus 5 is 7. 7 to the 7th. Okay, same idea. This is 5 divided by 5. They have the same base, which means we can just subtract the exponents. So this equals 5 to the 1 minus 1/3. Hopefully you can do that in your head. 1 minus 1/3 is 2/3. But once again, I told you, you can put that in the calculator. Type in 1 minus parentheses 1/3 you get 2/3. So 5 to the 2/3 power is your answer. So be able to use that property. Next property, a little bit more complicated, right? 42 to 1/3 divided by 6 to 1/3, all squared. So let's square the top, which becomes 42 to the 1/3 times 2, 2/3, over 6 to the 1/3 times 2, power to a power, 2/3. But look what we have here. We have something to the 2/3 divided by something to the 2/3. What if we went backwards? Wouldn't this be something all to the 2/3 power? If we did it backwards, wouldn't this be 42 over 6 all to the 2/3? Right? Isn't this the same as this? I just went backwards. Okay. So since these are both to the 2/3, I pulled that 2/3 out and then put parentheses around 42/6. Why did I do that? Well, look, 42/6 I can do. 42 divided by 6 is 7. All right, I simplified the inside. 7 to the 2/3. Now I think the cube root of 7, no, nothing. Okay, so this is it. Final answer. So example 1, just knowing all your properties and be able to use fractions, which means rational exponents. So get good with fractions, know how to type them in your calculator, okay? But don't just rely on a calculator. Be able to do stuff like this where you say, okay, you got this, oh, I can pull that out here and then get this, I can simplify here. So be able to do example 1. All right, example 2. Let's use these properties inside of a word problem here. So it says a mammal's surface area in square centimeters. Now, if you all know what surface area is, if I draw you an animal, okay, there you go. I'm a pretty good animal drawer. I used to be an artist. That's pretty good. Okay. Yep, there you go. The surface area of this animal, okay, is how much area is covered by his whole body. So if we calculate how much area, front, back, top, bottom, how much he is covered, his surface is covered by, if I could calculate that, it's used by this formula right here, this model. Okay, now comparative to you, if you look at me, I cover a heck of a lot more surface area than you all do. Maybe than 2 or 3 you put together. Okay, so we could calculate that by this model right here. Now, what does it want? What does S mean? The surface area S, so that's how much surface area there is. What does K mean? Can be approximated by the model where M is the mass in grams. Okay, how much mass there is of this mammal. And K is just some constant. So it tells you all the values of K down here. Approximate the surface area of a rabbit that has a mass of 3.4 kilograms or this many grams. So it says mass has to be in grams. So we have to take this right here. So all you got to do is do this. S equals K, M to the 2/3 power. Plug in what you know. What do they tell you? Approximate the surface area. Basically, find the surface area. Okay, find S equal to of a rabbit. Here you go. Then mass of 3.4 kilograms, this many grams. So K is the constant, which is shown here. K is the constant, 9.75 times M, our mass, which is 3.4 times 10 to the 3rd grams, but that has to be to the 2/3 power up here. So 2/3. Now, you have to use your properties. 3.4 times 10 to the 3rd, all to the 2/3 power means I have to take 3.4 to the 2/3, 10 to the 3rd to the 2/3. Okay, all times 9.75. So S equals Km 2/3. K is 9.75. K is 3.4 times 10 to the 3rd, all to the 2/3 power. So here we go. 9.75 times 3.4 to the 2/3. Just take this to the 2/3 times 10 to the third. Take this guy to the 2/3. All you got to do is basically type this in your calculator, and you got your answer on how much surface area is here. Okay, so let's do that. Okay, so if we type this in our calculator, we can do it a couple ways, but let's type it in like this. 9.75. It's whatever we had last. Parenthesis 3.4 end parenthesis to the 2/3 power. So anytime you put powers in here, like a rational power, you want to put parentheses. To the parenthesis 2 divided by 3 power end parentheses. See that? 3.4 to the 2/3 power times. If we did this in our head, it's 10 to the third to the 2/3. So really, 10 to the third to the 2/3 becomes 10 squared. So you can just write 10, and then over here's a square. There you go. So if we type this in, we're going to get, here we go, 2204.57. Now let's go back to the problem here. Just remember 2204. So we're looking for S, which is surface area, is in square centimeters. So you had 2204. So about 2204 centimeters squared is the surface area of this rabbit with this much mass. Okay, so that's how you use it in a word problem. I'm going to do about half of this section for you guys, so just to kind of keep it simpler for you so you're not too overwhelmed. Example 3, we're going to use some more properties of radicals. Though we just use properties of exponents like 7/1/2, times 7 to the 1/4. We add those up, get 7 to some power, 1/2 and 1/4. Well, let's see, that's 2/4 plus 1/4 is 3/4. Okay, so we use properties of rational exponents. Now we're going to use properties of radicals. Now you've actually done something like this. You've done like square roots, right? Square root of, we'll say 8 times the square root of 2. We'll just keep it simple. What could you do with this? Well, 8. There's a couple things you could do. You could say, okay, square root of 8 is, if you did it by itself, what? Square root of 4, breaking it down, right? Square root of 4 and square root of 2. And this doesn't break down, so we just write it square root of 2. So square root of 4, you say, okay, that's 2 whole. Square root of 2 times square root of 2. So times it by square root of 2 to square root of 2, which is just 2, which equals 4 total, right? That's one way to do it. The other way to do it is just do this. The other way to use the property here is you could just multiply these two roots together, like square root of 8 square root of 2. You can say it's square root of 16, which right away gives you 4. So you can break it up and kind of do it if that's easier than doing it this way. Square root of 8 square root of 2 makes square root of 16, which makes square root of 4. So just be able to use your properties, okay? Don't just kind of know the properties. Know them inside and out. Know them well, okay? Backwards and forwards. So let's do some properties with things other than square roots. We're going to do cube roots, fourth roots, fifth roots. So you guys got to be good at that. So here we go. Use properties for this one. So here's what I see. For this one, you could break it up individually. I wouldn't, because then you'd have the cube root of 12 is 4 and 3. Right? Cube root of 4, that doesn't do anything. Cube root of 3, that doesn't do anything. Neither of them are cubes. So it doesn't help us to break down 12. It doesn't help us to break down 18 even. Like 18 is 9 and 2. So cube root of 9 doesn't help us. Cube root of 2 doesn't help us. So it doesn't help us to actually break these down. So my suggestion is, let's put them together. 12 So cube root of 12 times cube root of 18. Let's put them together and make one big cube root, which is 216 if you multiply 12 and 18 together. Now there is an answer for cube root of 216, and that answer is 6. So sometimes it works out nice like this. Sometimes you want to break this down, get an answer, break this down, get an answer. You have to decide which one you want to do. Okay, it's easier to sometimes put them both together to make one and then do this. Okay, what should I have you do? In the calculator, if you don't know where your cube root is, let's go to it. I'll just show you real quick. Cube root, if you want to do it. Clear this, go under math, and you see it right here, number 4, and you have a little 3 there as an index, and then you see a root, so that means the third root or the cube root. So you can choose that. We can do it real quick, number 4, and then type in 216 in parentheses just in case, enter, there you go, cube root of 216 is 6. Okay, but if you did cube root of 12, number 4, we can just say 12. That's going to give you a decimal. Okay, it's irrational. Okay, there 12 is not a cube, so when you do the cube root of it, you're going to get some kind of weird decimal. So be careful. That's why you got to know. That's why you can't rely on the calculator. You got to know your stuff. Okay, and you know how to combine things. Let's get back to the slide here. Combine them. That's the property used here. We combine 12 and 8 together. All right. What if you're dividing? Now, like I said, there's a couple ways to go, right? They're both fourth root of 80 divided by fourth root of 5. Since they're both the fourth root, you can say the fourth root of 80 divided by 5. You see how I, kind of like the previous problem I did, I just kind of put it all together because they both had fourth root. So 80 over 5. Which that means that's the fourth root of 80 fifths is 5 into 80, it's 130, so 16. So we got fourth root of 16, which then it nicely works out. Fourth root of 16. You could look at 16 like this. 16 is a fourth power. Like 16 is 2 to the fourth. So I'm going to change 16 to 2 to the fourth. So watch. What is the fourth root of 2 to the fourth power? Well, the fourth root and the fourth power, those things cancel out, and you're left with 2. Okay, so you guys got to get comfortable with this. The fourth root of 16, that means something to the fourth gives me 16. Answer, 2. Okay, so I like to break it down like this sometimes, and then like the cube root of 2 cubed. Well, cube root of 2 cubed, that's 2. You see how that works? Fourth root of 2 to the fourth, that's 2. Answer is 2. Okay, so know those properties. Let's see. Do another one here. The cube root of 135. This is tricky because you have to break it up into things that work. Okay, so since it ends in a 5, we'll break it up. 5 times, if you divide this by 5, that's 27. So just like a square root, you guys are used to doing this. Square root of, what's good? 18. We'll do square root of 18. You guys are going to say, okay, square root of 18, that's square root of 9. Square root of 2. Oh, that's equal to 3 roots of 2. You guys are getting pretty good at that. But once I start throwing different indexes at you besides a square, people get confused. So here we go. The cube root of this. Well, let's break it up. That means that's the cube root of 5 times the cube root of 27. So we're not looking for squares anymore because this is a cube root. So we're actually looking for cubes. Is 5 a cube? Nope. So cube root of 5, can't do it. Just leave it. Cube root of 5. Is 27 a cube? Yes, it is. It's 3 cubed. So cube root of 27, off to the side, you might be thinking this. The cube root of, instead of 27, you could say 3 cubed. Look at that. Cube root of 3 cubed. You know the answer to that, I hope. 3. Notice how the index and the power cancel out, left with 3. So the cube root of 27, what cubed is 27? 3 whole. This is your final answer. So when I have 3 here, I'm looking for cubes. When I have a 4 in the index, I'm looking for 4th roots, like 16. Oh, that's 2 to the 4th. Yeah, it works out. Answer 2, just like the last problem.